Good morning, it's me, Mr. True. I'm back with another lesson in geometry. Today we are going to be looking at arc length and area of a sector. So in our last couple class days we've been working on circumference and area, and today we're going to put both those to use in something called arc length and area of a sector. So before we get too far into this, I want to go over what's an arc. So when we talk about the word arc, we are talking about a portion of a circle. So if you have the entire circumference goes all the way around a circle, that's 360 degrees. One arc is when you take and you start to portion that. If you look at, for example, your clock, each one of the numbers on your clock is a specific arc. There are 360 degrees, and if you divide that by 12, each number on that clock has an arc length of 30. So 30 times 12 gives you 360. Those are called arcs. So when I look at my first one here, I ask you to find a measure of each arc. Well, when I figure out an arc, if I'm given two letters, I need to go directly from A to D without any, there's no clockwise or counterclockwise. You just go directly from A to D. So I take the shortest path. In this case, if I go from A to D, I can see that that would be 90 degrees. Because you see the square here makes that 90 degrees. So that length, the arc AD, is 90 degrees. It is 90 degrees of the total 360 that goes around a circle. However, when I use three letters, that tells you that you need to go in a specific direction. You need to make sure that you go in order from A to C to B. So if you go from A to C, that's 180 degrees. And then from C to B. Well, before you start these problems, I normally suggest that you fill in things like, I know this is 60 degrees because half of a circle is 180. So I know that also if this is 90, then this one has to be 90. So when I say from A to C to B, that would be 180 plus 60, or 240 degrees. Now if I say BAD, well, if I go from B to A, then to D, that would be 90 plus 120, which is 210. And then lastly, if I say A to C, note I didn't throw a third letter in there. Well, A to C, it wouldn't matter if I went clockwise or counterclockwise or clockwise, because from A to C is what you call a semicircle, that's half of it, and that would be 180 degrees. So we have also something called major arcs and minor arcs. And when we talk about, for example, AD, that is a minor arc. A minor arc is an arc that is less than 180 degrees. So AD is a minor arc, major arc, and then this is called a semicircle. So we call these actually minor arc, and then this is not either a minor or a major, it's called a semicircle. So, on to the next section. So what we're going to be doing today is we're going to be taking that thing called an arc, and we're going to be working with, for example, this circle, and I need to figure out, according to this, it says it wants me to find what is the arc length of AB in terms of pi. So I'm asking you for the exact distance from A to B. I want to know the exact number of, in this case, feet from A to B. So what I do is, like I do with circumference was a measure to go all the way around a circle, but I don't want to do that. I only want to go with just this tiny little portion. So what I'm going to do is I'm going to take circumference, which is 2 pi r, and my radius is 5, and I'm going to multiply it by the part that I want. I don't want the whole circle, I only want 30 degrees of the total 360. I just want that small part. All right, so before I do this, I can see that I'm going to have, we've got quite a bit of multiplying. So when I do this, if I say 2 times 5, I get 10, and 10 times 30 is 300 pi over 360. Now the answer says leave my answer in terms of pi. So again, 2 times 5 is 10, and 10 times 30 is 300 divided by 360. Now I can't leave my answer like that because that answer right there has not been reduced. So if I think about what number would go into 300 that also goes into 360, the largest number that would be is they both divide by the number 60. And that's going to take a little bit of trial and error on your end. You might have to start dividing by 2s or whatever you can to get the number down. 2s, 10s, 5s. But if you divide both of those numbers by 60, your best answer in lowest terms would be 5 pi over 6. Now, if I want to know the exact answer, like right down to literally to the most exact term I could get, I would just take 5 times 3.14 and then divide by 6. And I would get that this length to the nearest foot is 2.6 feet. If I had to get the exact answer. Again, the answer asked me in terms of pi. So if we're looking at something like the FSA, day 1, they would probably have us give the answer in pi. If we were doing like a word problem application, they'd probably want the answer to the nearest foot or to the 1/10 of a foot. All right, so with that being said and done, let's look at the next one, which is another thing that we covered, which was areas of a circle. So when I found area of a circle, I used the formula pi r squared. But I don't want the area of the whole circle, I only want the shaded region. So when I look at that, I can tell that this is 90 degrees, and since circles make 360, the unshaded region is 90, but the shaded region is 270 degrees. So what I'm going to do is I'm going to use my formula for area, pi 7 squared, and I'm going to times it by the part that I want. I want 270 of the 360 degrees. When I start to multiply that, I see right away I'm going to have a crazy big number. I'm going to get 49 pi times 270, all divided by 360. Maybe I should try to reduce now before I multiply, because I'm seeing a really big number that I don't think I'm going to be able to do. So let's see, being as though that's 90 degrees, 270 and 360 both divide by the number 90. So I'm going to go ahead and do that now. And that's going to give me 49 pi times 3/4. When I multiply that out, I get 147 pi over 4. Again, the answer says, normally they'll say leave in terms of pi. I forgot to write that down, but that's all good. If I want to know the exact answer, I take 147, times it by 3.14, and divide it by 4. And I get an area of 115 square inches. 115.4 inches square. All right, my last and final example that we're going to look at today is how to work backwards on a problem. So when I read this problem, it says the area of a sector measuring 120 degrees is 85 inches squared. To the nearest whole number, what is the radius? All right, so again, I'm going to back it up and say area of a sector. Well, I need to start off with that formula. So area of a sector is pi r squared times the degrees, which is in this case is 120, out of 360. And the problem says the area of the sector, so I wrote down the formula, is 85, which means equals 85. All right, so I'm going to try to figure out what radius is. So I've got to work backwards. So the first thing I'm going to do with this is I'm going to get rid of fractions because I can't stand dealing with fractions. So seeing that 360 on the bottom as a fraction, I'm going to multiply this side by 360. I'm going to do it over here as well, and that gives me the ability to cancel out the 360. So now if you look at what I've got pi r squared times 120 equals, that's going to be a big number. Let's see, what's 85 times 360? 30,600. Big number. That's all right, because what I'm going to turn around and do right now is, to get to r, I got to start dividing. So I'm going to start by dividing by 120. So when you divide by 120, you get 255. So now I've got pi r squared 255. Well, if you divide by pi, you get, I've got now r squared equals 81.2. I just want r. So hitting the square root button to the nearest whole number, r is going to be equal to approximately 9. And that's it for arc length and area of a sector. Hope this helps. Bye.